Hi there. So it's another live revision question, daily revision question for you guys. This one is about acceleration, and it's about this car. And it is the acceleration of this car is listed as 0 to 60, that's 0 to 60 miles per hour in 8.7 seconds. So your challenge, your question is to calculate the acceleration of this car in meters per second squared, and give your answer to two significant figures. Now there's bonus ideas as always. Okay, so what assumption have you had to make that calculation of the acceleration? How would your calculated answer compare to the real answer of the maximum acceleration of that car? So your calculated one, would it be higher or lower than the maximum acceleration of that car? And then describe a method that you could use to give a more accurate maximum acceleration for this car. So that, once again, the 0 to 60 of this car is 8.7 seconds, okay? That's how we list and how you refer to accelerations in cars, 0 to 60 miles per hour and a time for that. Calculate that in meters per second squared, and then go ahead and give that to two significant figures. So it's an important skill to be able to do. Right, yesterday's question was just somebody arriving back into our into our drive here. Yesterday's question was all about calculating G by freefall, and there's some really good answers. So go back to yesterday's live feed and find those answers there. There's some really good examples. Human Snake's answer was really good. Basically, vary height, measure time, and then plot 2h over t squared. So whatever the heights were, multiply that column by 2, plot that on the y-axis, t squared on the x-axis, and the gradient then would give you directly g. Human Snake's result gave you the gradient as half g, so you'd have to, or 2g, I can't quite remember. But I like to put those constants on the axes, so your gradient is directly gravitational acceleration in that case. There's a video there. If you look back at the comments, the last one, I've put some videos of things to explain that as well. Also, Harriet's method just took one reading. That's what you'd expect from a GCSE group, and then use v squared equals u squared minus 2as, which is the equation of linear motion that you have to use in GCSE, and that was absolutely fine. But remember that well, if you just do the distance the thing travels and divide it by the time, then that gives the average speed, not the final speed. Okay, so just remember that whenever you are doing whenever you're doing with acceleration, then you can calculate the average speed and multiply that by 2 to give the final speed. You know, the initial speed in this experiment was just was 0 because, well, you started it from 0. That was pretty good though, really good actually, a lot of the answers into this one. Also think about, why was it a tape measure they'd given you rather than a meter ruler? And the answer to that, think, well, that could be a clue to giving a certain range, okay? I will have a look into the chat after I've just chatted through these answers. So the range for this, I think, needs to be above 1 meter, and you can't accurately measure things larger than 1 meter with a meter ruler. Okay, so think about saying measure heights from 0.5 meters to about 2 meters. There's some great detail about accuracy, for example, using markers and avoiding parallax error, so being at eye level to a scale. Although nobody talked about repeats, which surprised me. This is going to give you quite a lot of random uncertainty, so do talk about repeating and spotting anomalies and calculating averages if you've got random errors in this. Light gates are okay, although most light gates you wouldn't really fit a tennis ball very accurately through, but you could have a larger light gate, I guess. There's a video for that as well that I made. Video analysis is great as well. Loads of people, when they talk about the video analysis, sorry Lane, sorry Lane, did talk about repeats. Video analysis is great. Lots of people, when they talk about video analysis, they talk about film a stopwatch in the video as well. That's not quite as good as like just actually using video analysis software, but something to say that you could get the time from a video by either using a time code or by doing tracking or by playing back in slow motion is absolutely fine. Or to say use video analysis to get a more accurate time should be fine. And I've got loads of videos on video analysis as well. And lastly, there's nothing in the question stated that you didn't need to use a pendulum method. So Lane's pendulum method was perfectly valid, although I was thinking you'd go G by freefall method, but that's absolutely fine. Because they didn't say use a freefall method. Repeat of this question for today then, and I'll see you tomorrow for the answers. The 0 to 60 of this car is 8.7 seconds, calculate the acceleration in meters per second squared, and give the answer to two significant figures with some bonus ideas. Well, what assumption did you have to make? And compare your calculated value to the actual maximum acceleration of a car such as this, or any car really. There's some good ideas in there. And how would you actually make an experiment to more accurately measure that maximum acceleration? All right, so I'll just have a really quick look at the chat, and then I will say ta-ra and see you kind of next time. Let's have a quick check. I think there was a bit about uncertainty. Does the time constant usually have to be less than the time period when there's a set frequency for a capacitor? I know what you're talking about, set frequency for capacitor circuit. So you're talking about a capacitor that's charging and discharging. Yeah, the time constant should be like a fraction, like at least a fifth. I think I even know the question that you're talking about there. Basically, if the time constant is the time at which it will be at like 60, I can't remember off the top of my head. It's that 0.37 seconds. So if you plug in t equals RC, then you get e to the power of 1. So yeah, basically if the time constant is way less than the time period, then it will have discharged during that frequency of AC, during that cycle of AC, if that makes sense. So that's I think what you're talking about. Rachel was asking about history of the model of the atom. Is such a good 6 marker. Do you think it will come up, or what other likely 6 markers, atomic 6 markers could there be? Yeah, I think that is not a prediction. You know, I don't like predictions much. Yeah, that is a really likely 6 marker. I think. I don't think just doing all the details. Often though, that the big teaching point in that is why we change models. So we get new evidence that changes models. Okay, when new evidence doesn't agree with our old model, then we change or improve our models. Useful to look at some A-level videos. Will it help get? Yeah, I think so, definitely, Jack. I think that's a really good idea, especially things like the A-level versions of your practicals. So if you're okay understanding that whole graphical method that we've just talked through for G by freefall, then that's going to be really good understanding for, you know, how graphs work and how gradients work of graphs, to help you with those really tricky A-level ones. Just make sure that it's topics that are on the GCSE as well. Yeah, sorry, 0.37 of its original value. Thanks, Lane. Yeah, that's what I was going to say, and I think that's too slow. So if that makes sense, then yeah, you need at least sort of 2 or 3 time constants to pass before it's like roughly 0, if that makes sense. So I think, you know, if it's been 5 time constants, if you work out 0.37 to the power of 5, then that's pretty close to 0 at that point, if that makes sense. I'm not doing any predictions, buddy. Oh, so you need the capacitor to complete discharge before the next cycle. Yeah, if you want to see the full kind of discharging curve, which is often what you want. Otherwise, you still see a exponential discharge curve, but it doesn't get quite to 0. So obviously, this exponential curve never quite meets 0, but it doesn't get to 0 within those 2 or 3 significant figures. Well, that's great. Is the uncertainty of an instrument the lowest count or the lowest count divided by 2? It's just use the lowest scale division, okay, is the absolutely basic thing just to think about it. So whatever instrument you've got, a scale division is the uncertainty. If you think about it as being plus or minus half a scale division, then a full scale division is the uncertainty that you've got. Now, they don't really mind too much if you use half a scale division or use a full scale division as your absolute uncertainty. In fact, all exam boards have pretty much said now that they'll accept either. Okay, so they'll accept a full scale division as being an uncertainty or half a scale division as being an uncertainty, and they'll just follow your method through with whatever you decide to use of that. All right. I am an examiner. It's actually, we shouldn't tell you which exam board or exam level we examine for. No, the calculation's not too late. Leave it in the real comments, Adine, if that's all right, and try and answer the rest of the question as well. So, are physics exam papers checked by physics exam teachers? Yeah, the people who write them normally are teachers. They're often retired teachers or now part-time teachers. I have done some writing of exam questions. So I guess to say they're checked by teachers. We don't check them all. We don't all get to see them. But we do check. They're obviously really quite well checked before they come up. There was one more question I thought I would just look at. Oh no, I was just going to say the question again. Do leave the comments, have a little go. almost finished a kind of week of these things. I hope you're enjoying them. Some really good answers, been really impressed. Some people are sending them by email as well, which is perfectly fine if you want to do that. If you've got any other ideas, kit@gorillaphysics.com is the email address. You're very welcome to do that. If you've got any kind of feedback on what you like or don't like about these kind of daily revision questions, I'd like to keep this going up until the exam and use this as a model for next year. Maybe there's some things that you might want to change about that. So this is about this car. Calculate the acceleration. It's 8.7 seconds from 0 to 60, but also how would that value compare to the real value of maximum acceleration? And how could you design an experiment to actually measure that maximum acceleration? We make every effort to read everybody's handwriting. I've had times where I've taken a little bit of time over zooming in to make sure that I can read somebody's. I promise you, we make every effort, and if we can't read it off the screen, then we'll actually get your physical paper and we make every effort to read your handwriting. And I'll be honest with you, it's only maybe once or twice in all the thousands and thousands of questions I've marked where I haven't been able to read somebody's handwriting. So don't worry too much about your handwriting, especially if it's going to like slow you down in the paper or worry you. I thought I did answer your uncertainty thing, Lane. So I was saying that basically uncertainty is plus or minus half a scale division. So if you just use a scale division, as in the lowest count of the instrument, as your absolute uncertainty. So with a ruler that's got a millimeter scale division, then you should use plus or minus 0.5 millimeters, because you could be kind of halfway either side of the scale that you're measuring. And so that means the uncertainty is 1 millimeter. So if you were measuring something with of 100 millimeters, then your uncertainty would be 1%. I hope that makes sense, buddy. All right. So thanks all, and I'll see you all tomorrow, and we'll chat through some answers to this one. Do leave them in your comments. I really want to know, what I can do to make you a bit more confident to leave your answers in the comments. Even if you don't go all the way, even if you don't fully understand it, just think about, because I might be able to say, that's good though, because you still get half the marks or something like that. So have a go in the comments, in the real comments for this video, and I look forward to